Now. Thank you for joining for our How AI is Shaping the Future of Scientific Knowledge webinar. I'm joined by our two speakers for today. So Sebastian, Senior Manager of Program Management Business Operations at Allen Institute for AI and Semantic Scholar, and Manisha, Vice President of Business Development at UNO. So just before we get started, there's a few things that I want to run through with you guys. If I can just change, there we go. Okay, so first of all, we are recording, so if you do miss anything or you want to watch this webinar again, we will be sending out a follow-up link in an email afterwards, and it will be on our YouTube channel as well. You are muted, so we can't hear you and we can't see you, so don't worry about any background noise. We also would please ask you to keep the questions for the speakers in the Q&A box. And then any general chit chat about technology, or if you can't hear us, please put that in the chat box, just because the differentiation helps us catch up later on and make sure that we can answer everyone's questions and just follow up with everyone as well. There will be 5 minutes at the end of Sebastian's presentation for questions first, and then Manisha will present, and then we will have a little bit more time again for questions at the end. So please, don't worry if you have a few more that we haven't managed to cover in the middle gap as well. But that is everything from me. So I'm going to pass over to Sebastian now and turn my video off, but I will be here in the background if you need me.
All right, let me go ahead and get my slides pulled up here. Great, so first presentation is from Semantic Scholar, and I'm going to talk to you about the work that we do to transform scientific research process using AI. My name is Sebastian Kohlmeier. I'm the Senior Manager of Business Operations at the Allen Institute for AI in Seattle, Washington. What I'll do is I'll walk through our story, tell you a little bit about who we are, next go into details about how we apply AI to transform scientific research. Talk a little bit about some specialized research tools and data sets that we provide, and then leave some time for Q&A at the end. Semantic Scholar is a project of the Allen Institute for AI. We're a nonprofit AI research institute that was founded by the late Microsoft co-founder Paul Allen in Seattle, Washington. Our mission is AI for the common good. And we have a number of projects at the Allen Institute that are all focused on AI research in different areas, including computer vision, systems that read and reason, common sense for AI, and then Semantic Scholar, which is focused on semantic literature search. Our journey so far, Semantic Scholar was started in 2015, and we launched just in computer science because that was our area of expertise, but have since branched out to cover all scientific domains. We now index more than 188 million research papers. We have more than 7.5 million monthly active users from across the world. Most of our users are outside of the United States, and more than 550 partnerships, including partnership with Open Athens to support institutional login on our website, and partnerships with scientific publishers, academic societies, etc., to index full text content on our website. Next, I'll talk to you, since this is an AI-focused webinar, about how we apply AI to transform scientific research. The core challenge and the reason why we started Semantic Scholar is because science has a problem of plenty. There's too much research being published, and researchers and scholars are suffering from information overload. More than 3 million papers were published in 2019, across tens of thousands of journals, and the volume is growing 5% year over year. To provide an example, around COVID-19 publication volume for the coronavirus crisis, that continues to ramp up, and we're seeing 2,500 new papers being published in 7 days on average, and that's obviously a challenge for researchers and scholars to keep up with and pull out relevant information to answer important research questions. So we started Semantic Scholar with the goal to make it easier to find and discover relevant research. Semantic Scholar is a free AI-powered research tool for scientific literature. You can find it on semanticscholar.org. On the right, you can see our homepage. What we do is we extract meaning using AI and identify connections between papers and surface that information on our websites to help scholars discover and understand research. And what this looks like is we have a number of different types of pages, and I'll show you what those are. On the right side, you can see an example of our paper detail page, where we surface metadata from a paper, and we either link to the publisher for full text access, or in this case, we link to the preprint PDF on archive. We provide a number of different features to facilitate content discovery. One is a comprehensive citation graph. You can see on the upper right, we've extracted citations for this paper that link to other papers. We provide paper recommendations. We also have author and topic pages. We pull in external content, including code libraries associated with the paper, videos, clinical trials, presentation slides that talk about a paper, all in an effort to help scholars and scientists understand a paper. We apply AI to make the data more useful. For example, we classify citations by their type, and we have 3 different types that we support: result citations, method citations, and background citations. And when you look at the citations themselves, you can see the actual snippets that we've extracted using AI and the classification we've associated with the citation to help a user understand why a paper cited another paper. We also use AI to disambiguate authors and cluster papers. The way that we cluster papers is by finding all the different versions and then creating a single canonical page for the paper where we link to the actual published version and the preprint to make it really easy to find the different versions and also get the latest data for a paper. We also disambiguate authors automatically and auto-generate author pages. Scholars and researchers can also claim their pages to curate the information as needed. We have a comprehensive search engine where you can search across our entire corpus. We also provide other features like email alerts, where we've done a few innovative things like calling out which paper is cited for new citations that are shown in the alerts. We also surface new papers for authors. We have alerts for an adaptive feed that we've created, etc. We have an adaptive research feed that we've built that currently supports new preprints that are published on archive and also COVID-19 research. And this feed adapts based on ratings that the user provides, and the user can then edit their ratings to fine-tune their feed. We also provide a number of AI-powered research tools and data sets that are a little bit more specialized to solve specific research problems. An example of this is the COVID-19 data set, which is a COVID-19 open research data set that we created in conjunction with a call to action from the White House and in collaboration with a number of institutions listed below. This data set was released in March to tackle the COVID-19 pandemic. It contains more than 134,000 papers and is part of a Kaggle machine learning challenge to answer questions about the coronavirus, and is being used across the globe by researchers to answer questions about coronavirus. It's been downloaded more than 200,000 times since it was released 3 months ago. We also created a tool that runs on top of the COVID-19 dataset called SciSite. that enables researchers to investigate networks of science. One of the things that we found early on is that there's a lot of duplication of effort in COVID-19 research. So we've created a network of science tool that enables researchers to find out who's working on what type of research problem, to either reach out for collaboration opportunities or to avoid duplication of effort. And we also have co-mentions of proteins, genes, and cells, and co-mentions of diseases and chemicals as a way to explore the literature. And then finally, we recently created another tool called Sub.ai that enables researchers to uncover supplement drug interactions from scientific literature. This is a highly unregulated area, and we wanted to create a tool that enables researchers to find this information easily and uncover the associated papers that provide supporting evidence. That's all I have for today. I'd be happy to take any questions that anybody has.
Yeah, so we have one question. Oh, no, we have a few more questions coming in now. The first one is, what stack do you use?
I'm sorry, what stack do we use in terms of our technical stack?
I'm presuming so. We haven't got anything else from it yet.
Oh, okay. I'm happy to speak to that. We actually work the Semantic Scholar website, and our underlying infrastructure is run off of it runs off the cloud, and we actually use all three major cloud providers, including Amazon, Microsoft, and Google, for a variety of different tasks. So I'd be happy to follow up if someone has specific questions about that.
No, that's perfect. I think it was, yeah, in terms of technical. Another question we have is, I'm a librarian working in HE. I'm curious, where is this free resource / pulling source full text documents from?
Yeah, that's a great
content online only.
Yeah, that's a great question. So in terms of how we index content, as I mentioned earlier, we have partnerships with more than 550 publishers, academic societies, and research organizations that provide us with full text content to index. In cases where a publisher provides us with a license, we can't redistribute the full text, but we are able to index it, and then we link to the publisher for full text access. We do work with Unpaywall to link to third-party websites that are providing open access content. So we add open access links where those are available. We do link to preprints when those are available as well.
Perfect, thank you. We also have one that says, how are highly influential papers flagged?
Yeah, that's a great question. So we have different concepts of citations. We have raw citation counts, and we also have a concept of highly influential citations that we surface. And the way that we define highly influential citations is to exclude self-citations and basically focus the raw citations, make them a little bit more impact focused. We are actually working on some follow-up research here in an effort to come up with even better bibliometrics. It's something that our research team is actively focused on, because we understand that citations are not citations have many issues. They're great for exploring connections between papers, but they also there's also the rich get richer type of problem. So there is, this is something that one of our research focus areas for later this year.
Perfect, thank you. We have another question here that just says, can you elaborate on echo chamber prevention?
Oh yeah, okay. I'm assuming in the context of just seeing what you let me see if I can understand the question. I think by echo chamber you mean seeing things that you already know that you should be seeing, rather than seeing things that you're not expecting. Yeah, the way that we solve some of this, you know, I can maybe talk a little bit about our adaptive feed. Is we try to help users stay up to date and surfacing, you know, relevant research based on using personalized recommendations. So, you know, based on ratings that you've provided. So in some, you know, that helps you get the latest and greatest research from that perspective. And then, you know, of course, there's also, you know, if you're following authors on our website and looking for the latest and greatest, you know, looking for new papers and citations, that gives you another way to stay up to date as well. But solving that problem, having said that, you know, the echo chamber problem is a very difficult challenge. And if you're welcome to reach out if you have specific use cases. Be happy to walk through those.
We have another one that just says, as a librarian, I spend a lot of time doing complex literature searches. How would the Semantic Scholar search fit with this? As a supplement or an alternative, we are generally aiming for a degree of comprehensiveness rather than a best first answer.
Yeah, that's a great question. In terms of comprehensiveness, you are, you know, going to find all of the content that you would expect in Semantic Scholar. We index, you know, a number of large metadata resources, including PubMed, Microsoft Academic, and, you know, as I said earlier, we have, you know, partnership agreements with large publishers, including Springer Nature, Wolters Kluwer, Taylor and Francis, etc. And, you know, from that perspective, we do, you know, we have comprehensive information available. And then, of course, you know, on the site itself, you can then you can obviously search our corpus, and then you can view the individual papers and authors as well.
I think this will probably be one of our final questions now, just before we move on. So we have another one that just says, do you use any sources beyond the corpus itself to disambiguate names? For example, name authorities, Wikidata.
Yeah, that's a great question. We do use ORCID data to disambiguate names to an extent. We also look at things like the topics that an author writes about, and actually have our research teams actively working on author disambiguation, because it's a continuous challenge that we want to improve on. So that's you know, some of the other things that we're looking at are publicly available. You know, we're looking at crawling publicly available author websites, etc., associating that information with author profiles. So there's a lot of we are you know, actively and continually investing in that.
This last question kind of leads on to that as well, which just says, what are your plans for development? Might you in the future look towards the use of AI to actually critically review evidence within a clinical area and provide summary recommendations from across all papers on that subject?
Yeah, that's a great question. It is, you know, one of the areas that we are actively looking at is review, working in the review automation space. It's a little bit early days from that perspective, but we are in active collaboration with Cochrane on a project on that right now. Summarization is something that we're very interested in, and a direction that we want to go in.
Perfect. Thank you very much. Okay, so that's the first question and answer section just done. So I'm going to pass back over to Manisha now to present for you guys.
Okay. Oh, sorry. I'm just gonna go to my first slide. I don't know why it's done that. Sorry. All right, so hi everyone, I'm Manisha and I work for So today I'm going to be talking about two things. Great search results rely on two things, don't they? The content set you're searching and the technology you're using. The trouble is, even if you have both these things, you will now probably be overwhelmed by the size of your results lists. Today, the issue is about finding what you're looking for from all the information available with the time that you have at your disposal. Additionally, free search tools have further compounded the challenge as bias is introduced into the ranking of results, which is impossible for a user to understand and correct. So how can AI help? The latest AI technology takes us from natural language processing, which is hunting for keywords, to neural networks that can actually understand what they're reading and identify meaning and context. This enables a whole new type of search tool that can take users not just to the document, but to the most relevant section of that document. For longer document formats, such as books and government reports, this gives them a whole new level of usefulness, as they can be reintroduced into searches where previously the user would have disregarded them due to their length. So there is definitely a role for librarians to fill in providing a comprehensive but curated ecosystem. Junior and novice researchers sometimes can't assess the quality of sources and may accidentally base conclusions on suboptimal sources. And also a place for libraries to help dealing with the volume of fragmentation of content sources and pull them into an environment that does not increase or inflate bias linked to suboptimal metadata. When we found we knew that we had an amazing AI technology that could help take traditional search to the next level. So just as Sebastian was talking about, the issue we face today is the overwhelming volume of content, but no more hours in the day and shrinking budgets, right? While there is a huge number out there free to read and open access available, it's quite fragmented across different websites, archives, and a huge range of other sources. And secondly, in taking that overwhelming and ever-growing content set and turning it into knowledge. And finally, bringing back serendipity into the digital world through showing connections and inferences. So this is a famous quote from a Davos panel several years ago. And in this talk, I want to cover what the quote means. In terms of how AI can drive time saving and efficiencies and remove some of the tedious and mundane elements of research and searching, and in many cases, not finding what you're looking for. There was a great statistic in one of the Charleston webinars that data preparation consumes 60 to 90% of the time needed to mine data and contributes 75 to 90% to the mining project success. So instead of spending all this time preparing data, I'm sure most of us would rather be focusing on the project itself. AI isn't magic, but it can certainly speed up things like gaps in semantic metadata at a fraction of the time. And it can also take us to a totally new place where instead of searching, we can actually discover. I want to talk about how we can apply AI technology so that content sets can not only unearth concepts and information that's hidden because it's too detailed to be covered in a traditional metadata schemas, and also how we can use AI to obtain knowledge and insights from that data. Once your content set is set, it is the structured format. You have a lot of well-organized content, but you can't necessarily find anything, and you don't necessarily know what you've got at a granular level. For example, if you adopted a single standard metadata format and all your bibliographic data, such as title, author, and publication date, is in order, that's a necessary start. But what if your semantic metadata is sparse or out of date? For example, if the keywords you're using were those in use when the book was published 20 years ago? What if the keywords have multiple meanings? Maybe the topics section is only relevant to part of the item, so useful content covered in the rest of the text will go unfound. Once your data is digitized and structured, the door is open to using AI technology to not only understand huge content sets, but also make connections and inferences across content to keep everything continuously updated in a knowledge graph. And I'm going to talk about that in the next couple of slides. Additionally, AI can mitigate any gaps that you have in your semantic metadata, as it will read the full text of the document. So in that way, you may be able to leapfrog over some of the challenges that can arise with older content sets and out of date, inconsistent, or non-existent semantic metadata. But just to be clear on the distinction between bibliographic and semantic data, you need basic bibliographic metadata, such as title, author, publication date. As I said, AI isn't magic and it cannot know these things. However, it can help with semantic metadata because it can not only read the full text, but it can also understand context and meaning. And I have a few examples of those. So where does fit in? So we are an AI technology company, but we are a semantic artificial intelligence organization. And we have created a technology that reads the full text of a document and mimics the way the human mind works, leading to enhanced discovery and exploration of content. And we've done that because we've done that using a knowledge graph. The basis of patent technology is that it leverages the power of a knowledge graph so that you can see what's really important to you. And let me explain. I promise I won't let it get too technical. So on the left-hand side, you will see a huge amount of content, different types, publication, frequencies, formats, and languages, all being read in real time or as frequently as they're published. In the center, you will see a series of algorithms that are recreating that neural network model I was telling you about. So they're trying to mimic the way the human brain understands information. On the right-hand side, you can see a knowledge graph, an enormous multi-dimensional semantic vector space where similar concepts are clustered together. So, for example, you will find Java, the programming language, closely related to Apple Inc., close to Microsoft, and other programming languages, while you'll find Java the coffee in a totally different place. And all these concepts and clusters of concepts are dynamically updated as new information is added. And that's vital to both content owners and researchers. In a knowledge graph, it's not just about showing the connections, it's also about being able to explain those connections. So each link in a knowledge graph carries meaning and will explain why two concepts are connected and the strength of that relationship. Now, a traditional database is great for organizing and structuring content and data, but it doesn't necessarily understand the content, whereas a knowledge graph, which has read and understood the full text of each document, can not only surface, it can show you the relevant part of that content. It can also make connections between concepts with documents that explain those connections. This therefore enables the user to derive knowledge from that information. Over the past years, we've seen graph representations pop up more frequently as people realize that a dynamic environment is critical to success. In terms of how technology graph can be used, it doesn't have to be visualized as a graph, although many people are visual learners and find this helpful. It can be the underlying technology, and a UI can take different forms. So today, I'm going to be talking about two different UIs. One is Discover and the power of that knowledge graph, and Unearth, which uses a knowledge graph to empower libraries or content curators to understand their repository and curate content sets. So here's Discover. It's a next generation AI-based research tool, which is powered by a knowledge graph. The knowledge graph reads over 250 million items of content from the entire spectrum of academia. That's open access content, subscribed content, publishers ingest the full text of their content into our system. So what it does, it reads the entire full text of a document and extracts meaning in the form of a concept. The example I'm giving you here is a scientific one, showing the relationship between multiple concepts. These concepts are based on the strength of that semantic connection, based on reading the full text of a document and extracting concepts that are found or inferred from the corpus of the content. When you click on a concept, you can go to the document section and find literature which is directly related to your search. Within Discover, you can't search by title, author, or publisher, but why would you? There are a great number of fantastic tools that allow you to do that, but looks at the content in an entirely different way. So here's another example where you can see the relationship between two concepts. And if you click on the strand between them, you can actually see the relationship between these two concepts and find the associated literature. So here's an example of a snippet taken from a De Gruyter article showing the relationship between urban planning and Strava and where that has been found in the text. Within the research tool, you can click on the link resolver, and that will take you to the documents for your institution, or we'll always provide a link back to the publisher. So here is De Gruyter. AI can identify concepts and keywords without being fed a list of terms. This is critical for any platform to be up to date. And with all new content being produced and language as it evolves, it is able to do this because it understands context and meaning. Concepts form atomic units of information and are categorized by the description and significance. A concept is not identified by its label, which is the word or group of words used to describe it. It is semantically categorized via definition and the set of topics or categories that it belongs to. So the benefits of this versus a traditional sort of keyword search are that as language evolves over time, you don't have to worry about remembering a previous name. The concept, because it's not identifying simply the word, but because the term carries this definition and can ensure comprehensive results. And it doesn't matter if the word changes over time, the relevant content will always be surfaced without having to update old semantic metadata. And you can do this right down to document level to the actual section of the text. So if you think about disambiguation, let's look at the word depression. There are several different meanings of depression, but you know, you really, if you're a geologist, you really don't want articles coming up that are about, for example, mental health issues. You really want those are pertaining to geology. And let's look at understanding context and meaning. So for example, on your right-hand side, this document from 1995 is actually talking about 3D printing, but the term 3D printing wasn't available then. So what the technology can do is read past, present, and future to identify, oh yes, 3D printing as a concept was mentioned in this article in 1995. Let me bring it up so this document will surface in that search result. So I'm going to now talk about on Earth. When we created Discover, content curators came to us and said, if you can read everything, you can also read my collection and tell me what's in it, because I really don't know. I want to improve discoverability of what is there, and also curate more precise reading material for research, which I know is embedded in here somewhere, but I don't know where. So it's going to take tons of time for a human to do it, and they probably won't be able to do it quickly and efficiently, and more importantly, it will form some kind of bias. So here's on Earth. This is reading the entire full text of a library repository and extracting documents and analysing them at topic, subtopic, and at concept level. So here's an example of one document which we've pulled out. You can see the topics and subtopics, but we've also pulled out the concepts and shown you where within the text that concept has been found as a reference point. We can surface about, I don't know, 70, 80 concepts per full text article, from an abstract, maybe 10, 11. So each concept, you want to understand why it's there and as a reference point. But what you can do is actually connect Discover and on Earth together. And for one institution, they wanted to be able to visualize the concepts coming out of their repository and see it within a knowledge graph. So here, for example, we've been able to understand through squares and circles which concepts are found within UNO's knowledge base, which are denoted by a circle, and which of those are denoted by a square, which is found within the repository of this particular institution. You can then also then filter by institution author, which allows you to then understand who the relevant authors are and connect back to the documents. So it's really important, this kind of data. You don't really need to necessarily have a UI, but you can extract the information using an API or a JSON or CSV file to enhance the semantic metadata that you have between your systems. And this is really good because you can do that with the information just in UNO's knowledge base, or you can do that together with those in your repository. If you do opt to have a UI, you can also think about how you could create a customized reading list based on topics, subtopics, and concepts, and download what that reading list could be for yourself. You can also take a very high level approach at understanding all your documents. And here you can understand how many documents there are, what the subtopics, and concepts are that are coming out of all your documents. You could also understand trends over different time periods. So here's an example of topics, but you could do the same thing with concepts. And if you wanted, you could also compare the data sets. For example, if you're a university that is strong in medicine, you can compare your medical library repository with content, with open access content sets, such as those from PubMed, for example. So you could understand trends over different time periods. So you may or may not need real time. And if you do not need real time, you will save a lot of money. However, if you want the concepts or keywords and other connections to be updated as often as the information is updated, whether that's daily or weekly or another time period, you may want to link your corpus to other information sources to understand trends. Regarding disambiguation, some natural language processing technologies do not disambiguate, so they will rarely offer single words such as apple. They will offer you things like tree or apple fruit. This is because the technology isn't actually reading the full text, it's understanding its meaning, it's just hunting for keywords. Understanding content is enormously important, partly because it's linked to the point above about the technology being able to disambiguate, and partly because it is what enables an accurate topic hierarchy to be put into place. This is what will help content owners or researchers identify sections of the text that the concept or keyword itself isn't mentioned, as I demonstrated above with the 3D printing example. It's absolutely critical that the system is genuinely recreating a neural network model and learning so that it can identify new concepts as they emerge, rather having to be fed them. Otherwise, it can never always be up to date. Finally, as we've discussed, the volume of content is overwhelming, and no human will ever be able to read an entire search list using a traditional method. Therefore, using a knowledge graph approach, where not only can the content owner surface the relevant content so the reader can find them, it can also suggest connections and inferences, some of which might be known and many will not be known, thus helping people find what they don't know to look for. That is true discovery. If you can answer yes to all 5 questions, you can sleep soundly knowing that you will never miss an opportunity for your content to be discoverable. Well, thank you very much. Please let me know if you have any questions.
Yeah, we do have a few questions. The first one is, how would students use Discover as opposed to a researcher?
Yeah, so for example, if you're an undergraduate student, this kind of technology would be really useful for like topic exploration. So if you think of something that's quite a large topic, let's think of something that I studied, like existentialism. It took me a good long while to actually realize what existentialism is as a topic, and then be able to see the relationships between Jean-Paul Sartre, Simone de Beauvoir, other French literary out there, existential as a movement, that kind of thing, and it can really help you to start working on an essay. In terms of a researcher, what's really good about this kind of tool is if you have a gut instinct about something and you want to understand if there's a connection between A, B, and Z, you can put it into this kind of tool and it will create a knowledge graph to show you if there are connections or not. Quite often there could be a connection between 2 concepts because the technology has read everything about it, but there might not be any documents. So this is telling you, hey researcher, I can see that there is something here that you might want to do some more research on. I'm telling you there's a semantic connection here, go off and do some research about it. So it's a great way to sort of help people think of new paths of research as well.
I think that one might have answered the second one, which is why is the knowledge graph important? So unless there's anything else you want to add on that one, then I'll probably move on to this one, which just says, is this just for English or is it also applicable to other languages?
So in terms of the library repository tool, we have worked in multiple languages before. So what we did with, for example, an Italian institution, they wanted to be able to understand their repository in English and Italian. So using a Google Translate API, they translated the abstracts and provided them to us in English. They did that with internal consultation of their faculty. They were happy for the content in English for UNO's technology to be able to read it and infer the concepts. So, for example, if you're studying something like knee surgery, you can look that up from English documents as well as Italian documents in one place. So, for example, even if knee surgery was inferred within a document, it would come up. We're also able to provide link backs to the text in Italian as well. So there's a lot here that can be done. We've tested the system in French and Spanish as well. So if you're an institution looking for another language, then we'd be interested to work with you.
We have another one which just says, in my field of health librarianship, it's really important that we evaluate the quality of the information/research output. Is there a way for UNO to incorporate critical appraisal?
Critical appraisal. I think that it could be something that we can incorporate. I think that what we would require is some samples of the documents, and we could see if that could be something that could be incorporated.
Thank you. We have another one that just says, are tools like Semantic Scholar and UNO typically integrated into existing library discovery systems, for example, Ex Libris Primo, or are they provided as a standalone system?
So I can just quickly answer that one from our perspective. We want UNO to be a part of the library ecosystem. We work with all the vendors, Ex Libris, EBSCO, etc., to provide things like widgets, and which can be used together with their library search tools. So it's all about using, for example, EDS or Primo to understand by topic or understand by title, author, etc., and then using UNO to understand wider than that. So yes, our products do work and are compatible to work together.
Perfect, thank you. Is there anything you wanted to add to that one, Sebastian? Are you happy to move on to the next question?
Yeah, I was just going to say, with Semantic Scholar is a standalone website that is free to access. Given that we're nonprofit, it's available to everybody. We do have for full text access. We partnered with Open Athens. If someone signs in with their institution, we provide a beta experience to provide full text access to users who have logged in with their institution. And we do have plans to further scale that out to provide more institutional access for users. But otherwise, the website is freely available to everybody.
Thank you. We have another question that just says, how new is UNO Unearth?
It's pretty new, to be honest. It's a technology that we have been working on for about 2 years. We rolled it out last year to a library to become a development partner with us. I probably started showing it at the back end of last year, and this year we're able to show it around to more institutions, and it's also a technology that we use for publishers as well.
We also have another one that says, can you specify your acquisition sources and compare that material to your own institution's publications to discover areas where your acquisition is lacking?
Yes, you can. Yeah, you can use that.
Perfect. And we have one final question at the moment that just says, are any universities using it?
Yes, we have over 100 institutions globally in 9 different countries. So we are a small organisation. The library partnerships are just controlled by myself. So yeah, we have a great number of institutions, large, small, top research institutions, and then we have small public libraries using it as well.
Perfect, thank you. Okay, so I'm going to give a few more, well, we have about 1 more minute left if there's any more questions to come through. If you do have any more, we can follow up afterwards, but if not, then we will end this webinar here, because I think that might be everything for now. I'll just hang on a second and see if any more do come through. Also, just to cover this again, because this has been asked, we are obviously recording this and it will be on our YouTube, and you will have a follow-up email as well with a link to it. We have one last question that just says, can you describe briefly how UNO interfaces with library systems?
Yes, so there are a few different ways that you can use it. You can include a widget within your EDS or Primo or whatever it is. You can provide it as a standalone system as well. So you can create a libguide, for example, or you can put a page on your library website where you can create information about there. But as far as like the main way we would ask you to probably use it would be within your library search systems and make it usable there. We try to make it, it's a cloud-based system, so it doesn't require any kind of like heavy integration to do that. If anybody wants any examples of all that, they can contact me afterwards. I can send you some screenshots or give you some live examples of how it looks in different universities.
Thank you. Okay, I think that's everything now, so I'm going to wrap this one up here. Thank you all for coming, and yeah, if you do have any questions, then please let me know, and we will be following up afterwards as well. So thank you very much.
Thank you.
Thank you.
Bye.
Bye.